Okay, hi everyone. So my name is Nikita Tuk. I'm iOS developer, and right now I'm working at coins.ph. It's a Philippine startup focused on providing bank services for unbanked people. Right now we have about 1 million clients whose territory located in Asia. It's Thailand, Philippines, Indonesia, and all other countries. But the most interesting part of my job about the place where I worked before. The place is called Yandex. It's one of the biggest IT Russian companies, where I worked for 2 years. And the project I was working on.
Please, can you use the microphone?
Sure. Is it better?
Maybe.
I think no. And now? Okay. I think it's not working. Oh, yeah. As I said before, I've been working in Yandex. It's one of the biggest IT Russian companies. And I've been working on a product that was called Yandex Disk. Yandex Disk is a cloud storage solution for iPhone, Android, mobile, and web. I'm also part of TopTel network. Yeah. I'm also part of TopTel network. It's a network of remote or freelancer developers who work across the globe for different clients. So today we're going to talk about handling background processes in iOS. As you might know, it was a really big pain for iOS for a long time, and you can't even have background syncing. But since the releasing of iOS 7, a lot of things has changed. Before going further, I would like to ask how many of you have ever developed an app that used background syncing on iOS? Okay. Oh, great. So for you, I think I will share some secret knowledge, or what's going on? Okay, for you, I think I will share our best approaches and our experiments. And for rest of the team, for rest of you, I will tell a little story about how iOS treats all this thing, and maybe you find something new that you can apply to your next project. So let's start. Can we do something about this? Okay. So let's start with Yandex Disk. As I said before, it's just an app that allows you to sync all your files, all your photos with your cloud storage. And sorry?
You can use presenter?
Yeah, I can.
Maybe this is a problem.
Yeah, can you use presenter?
Let's try this way. Okay, so you can sync your files with the server and access it across all your devices. I think it's a useful thing, and how do you think what is the most important feature for iOS and for iPhones that most of the users use? So the most popular feature is photos. All of iPhone users takes photos, and none of them has enough space to take photos. So the most important feature in Yandex Disk was, I think it's not related to. So the most important feature was photo syncing, and in Yandex Disk it's called auto-uploading. Yes, it's called auto-uploading, so believe me or not, it will be here on the next slide. And another important feature that allows you and helps you to sync your files with your mobile device is called offline files. So, for example, if you have some important docs for travel, or you have some important document stored on your server, and you always want to have the most recent changes on your phone, you can just mark your file as offline. No? Okay. Yes, it works. So, as I said before, we have a feature that was used for uploading photos from user devices to server. And another feature is really useful that allows you to sync all your files from server to your iPhone is offline. It's really, really useful features, both of them. I've used it multiple times. And it really helps a lot, especially when you're traveling. Sometimes you can get to the zone when you don't have a coverage or you're in a plane trying to find someone else contact that will meet you and all this stuff. So believe me, it's really important and very useful. Today I'm going to speak about several things, and I will use Yandex.Disk as the example of most of these things. So just get used to it. The first thing I would go and talk about how iOS apps works before iOS 7. Then I will tell you how it works now after iOS 7. Also, I will tell you about our experiments on background syncing and limitation with MED and problems with MED. Also, I will tell about testing, how we test everything, how our testers, what problem testers met when they were testing. And I will tell you best practices for our team that we used to make the app, because the app is really big and it's really complicated from engineering point of view. So let's talk about iOS 4. It was a revolutionary iOS, because before iOS 4 you don't have multitasking. So you just can't listen to music and surf web. You only just use one application at a time. iOS 4 introduced new state. So when you launch your phone, all of your apps are in state called is not running. When you tap the icon of an app, your app moves to the foreground. The foreground apps are the app that you see on your screen right now and you interact with. After you stop using the app, for example, you press the home button, app goes to suspended state. And it was really, really important thing, so you don't need anything else except one thing. In this scheme, you can't use app that, for example, downloads something in background. For example, user opens your app, tries to download something, then taps home button, and downloading stops. User comes back to your app and he doesn't see any downloaded file. User becomes angry. Angry users is not good for developers. So that's why, in addition to this interaction, there was one more state called background. So you can go from foreground to background. And in fact, apps doesn't go from foreground to suspended immediately. They have a background state that you can request from iOS. You can ask for 10 additional minutes to do all your stuff you need. So for example, to download file or to parse something, and then your app goes to suspended state. This was really, really important. But again, in this scheme, there is one big problem. What if you need to move from suspended states to background? Before introducing iOS 7, there were 3 types of apps that can do this. It was navigation apps. Of course, while you're traveling, you don't want to always launch your app and do something about this. You just mark your app as navigation, and that's all. You can leave in background. You can go from suspended to background, whatever you need. Another type of app is music players. Of course, it seems very logical to have an app that lives in background without user interaction. And the third is voice over IP calls. Unfortunately, if your app doesn't fall in one of these categories, you can't do anything about this. You can't go from suspended to background. Of course, you can mark your app as one of these and hope that Apple won't ban you for providing misleading information. But the truth is, in 1 or 2 releases, you will be banned. You will be rejected from App Store, and you won't be able to use these wonderful features. Especially, the problem arises when you're developing your app for some long period of time, and then you realize that you can't be uploaded to an App Store. So what was the new about iOS 7 and why it's again, revolutionary in terms of background. iOS 7 introduced three interesting things that is very important for background and background syncing. The first one is called NSURLSession. The second one is silent notifications. And the third one is background fetch. So I'm going to talk about this a little bit more so you understand how it works and why it's important. Let's see again our picture. As I said before, there was no way to move from suspended to background. All of these features allows you to move from suspended to background. And it is really, really cool and really, really important for developers. Unfortunately, there was two limitations. The first one, you can't move from suspended to background for more than 30 seconds. In fact, it's not very much, but there are a lot of things you can do. You can run synchronization, you can schedule new download, you can schedule new upload, and it helps you to make some kind of background synchronization. Another limitation that was introduced is moving from foreground to background is now limited only to 3 minutes. I think it's also a reasonable limitation because if you have some task that won't be finished in 3 minutes, you should consider moving it to background. Otherwise, there are high chance that you won't finish it at all in 3 minutes. So if you have small download, finish it in 3 minutes, otherwise don't risk to do it because otherwise socket will be broken and you can't download the file. So I'm going to talk about these things a little bit more and how to configure them and what are they doing actually. So silent notification is the special kind of notifications that was for a very, very long time on Android and iOS. But the only difference between real world and real notifications and silent notifications is that they don't trigger any UI changes on user device. So for example, you have updated your file in your cloud storage and you want to inform user's device that there is a new version of file. You can use regular notification and send it to your user, but user will see that new notification arrived and will start trying to do something. This is not what developers want. They just want to inform the device, not the user. For this purpose, Apple introduced silent notifications. So to configure silent notifications, you just omit all user-related information like alert, sound, and badge, and include that content is available. With this, Apple and iOS won't show anything on dashboard, I mean on the lock screen, and user won't even know that something happened. After server sends you a push notification, device gives you 30 seconds in background to do everything you need. After this, application will move from background to suspended state again. Another thing is background fetch. Background fetch is also a very interesting feature that was introduced also in iOS 7. It's a special thing that allows you to wake your application up in some particular period of time. Also, it's very complicated because you can't say that you want to wake up every 5 minutes. In fact, you can do it, but Apple will ignore this information and will wake up based on really, really complicated logic that is not really clear how it works. And there are a lot of reasons to wake you up and not to wake you up at any particular time. So if you go to Apple documentation and see it's affected by Wi-Fi or bad Wi-Fi, is it phone charged or not, is it charging, how many space on device you have, a lot of different things that affects this feature. But still, you need two things to configure this. The first one set minimum interval, how often you should be called, and the second one is just configuration in your file. It works similarly to silent push notifications, but the only difference is that you don't need server to be woken up. Just iOS wakes you up by calling your application, and you still have 30 seconds to do all you need to know. So the next thing I'm going to talk about is an NSURLSession. But before going to an NSURLSession, I'm going to tell you about an NSURL connection. It's the previous way to interact with servers. So the basic class for an NSURL connection is class itself, and it has a configuration. So if you make 3 connections, you should create 3 configurations for each connection. It was not really cool because you should share this configuration across all of them and recreate each time. Compared to an NSURLSession, it's totally different. So an NSURLSession is like a queue that allows you to create one single configuration, configure this queue, and then you create lightweight tasks and just add it to this session. After the tasks finish, it will call your app and tell that actually tasks has finished. Before going further, have anyone used an NSURLSession? Okay. I don't know how we develop apps for the last 3 years, but this is the way apps should be developed. If you haven't used an NSURLSession without any frameworks, I think you probably use one of Alma Fire or IF Networks. So both of them are using an NSURLSession underneath. So if you're using one of these frameworks, you're already using an NSURLSession. In Yandex Disk, we didn't use any of them. We just used an NSURLSession and built our own framework on top of this. Because by the time we did it, both of the frameworks was very raw and not really useful for building big applications. So there is a class called an NSURLSession task that is minimum unit that used to make a request to the server. There are different types of tasks. Each one is responsible for its own purpose. So the first one is an NSURLSession data task. An NSURLSession data task is is widely used. It works like an NSURL connection, and it's designed for making simple calls to a server. So, for example, if you need to make a POST request, if you need to fetch some use from server, you need to update user information, so an NSURL data task is what you need. Another task is an NSURLSession upload task. This is a task that is used to upload files from your sandbox on your iPhone to the server. So an NSURLSession download task is doing another thing. It downloads to your sandbox, to a temp folder, and gives you a callback that allows you to copy file from temp folder to final destination. If you don't do this, your file will be lost. And then the last task is stream task. It was introduced in iOS 10, so we haven't used it by ourselves because we still support iOS 8, and we can use it. If you can use it, I think you're a lucky one. So, and the most interesting part about the two tasks that I was talking before, upload and download task, that they can work in background. It's a really powerful feature because you don't need to have app running. You just make them, send it to an NSURLSession, and that's all. They will be working. Of course, they can fail somewhere in background, or they can succeed somewhere in background, and your app will be notified. Just to understand how it works underneath, I will tell you more about the interactions between your app and iOS. If you have MacBook or Mac Pro, you probably see a process called NSURLSession D on your app, on your Mac. It's the process that's responsible for syncing different data from Apple servers or different servers to your iOS or Mac device. So probably you see that this process takes a lot of data, especially if you're using iCloud or WhatsApp. It syncs a lot of data. So on your iPhones, you also have this process, and it's responsible for making different web calls. And this is how it works. So on your left is your app. You create a task and send it to an NSURLSession D process that is a daemon and writing independently of your app. And then after you create tasks, your app can go to background state and then go to suspended. It can even be stopped. All the tasks that was finished in NSURLSession D will also go back to your app, and it will wake your app and again give you 30 seconds to do anything you want. Usually it's post-processing of your task, so marking file or marking photos as uploaded or as downloaded. It depends on the type of the app. But general idea works independently of your app and gives you 30 seconds after it finishes. So also it's important to understand how background fetches work. So as I said before, it's a really complicated thing that understands that it's time to call your app or wake up your app. There's a special handler in iOS that is responsible for handling background fetches. Here is it. There is a special parameter called completion handler. This is a handler that you should call after finishing all your work. There's important notice on docs that you should call it before 30 seconds expires. If you fail to do this, it means a very, very bad thing for your app. iOS will think that your app is either have a bug that stops it from calling completion handler, or it fails to complete in 30 seconds because of some problems with your logic. It drains a lot of battery, it takes a lot of time to complete, and both of these scenarios are bad for users. So that's why Apple won't call you again. But again, it's according to the docs. You will see later that it's not true. So there is a parameter called fetch result. It allows you to update your screenshot in completion handler, in app switcher. If you, for example, download new file or somehow updated user UI, you can pass new data in completion handler and inform iOS that you need to create a new screenshot. So this is how it works. Right now I'm going to tell you about the experiment. When we started to work on Yandex Disk and background synchronization, it was totally new framework. It was not so much information on web, on how it works. Of course, there was Dropbox there, but no one would like to share their own secrets of how they build a product that brings their money. So that's why we have to run our own experiment, and this is the result. We wrote 8 apps. Some of them call completion handler immediately. Some of them fails to call it. Some of them takes a lot of time to call completion handler, download a lot of data, or actively uses battery, runs a lot of process, and then calls completion handler. So we expected to see some correlation between what we do in our background 30 seconds and how often we called. So as you can see, there are badges on the apps. The badges means that app was called. So for every background fetch we get, we add 1 badge. So as you can see, on the left we have iOS 8, and on the right iOS 10. iOS 10 is like 2 weeks testing, and iOS 8 is like 1 month testing. As you can see, there is no correlation. Some values are really high, some values are really low, but still every app got their portion of background fetches. We were really surprised about this, and we didn't know what to do. We can't somehow influence the probability of being called, and it was really frustrating. As you can see on the right screenshot here, I have no completion handler app that was called only 2 times, while the top app was called 25 times. As I said before, you should follow guidelines, and that's what we did. So we follow guidelines, and we call completion handler as early as possible, because that's what Apple wants us to do, and we hope that that will help us to get more background fetches. We also try to save battery life. Everything that we can do while user is using foreground, using the app in foreground, we did it there. So we moved all the code that we can from our 30 seconds handler, and I think it helped us. So, and we make sure we always call completion handler. In the last part of the talk, I will tell you how we did it and how we managed to make sure everything finished with the completion handler. But there was surprises in our experiments. As you can see, I spent 2 days clicking all the apps again. So our top app went from 25 calls to 32, and our app that has no completion handler, again, according to Apple Docs, you won't be called again, moved from 2 calls to 30 calls. I don't know how it works, why Apple allows you to use this app or allows you to call background fetches. I didn't update anything, but still Apple calls your app even without completion handler. Also have another experiment. I think most of you know that iOS device has some kind of heuristic that allows you to predict allows it to predict what app will you use and how you will use it and when you will use it. At least if you see the latest presentation from Apple, they say that it can predict your contact that will talk with you right now, the meeting you should go, and etc. And idea was the following. So, for example, imagine you're waking up, you take your phone, and for me, I do 2 tasks every morning, every time I wake up. So I check my mail, and I check my Slack. So, in our opinion, if Apple says they're kind of heuristic, Apple will be woken up like 5 minutes before me, get all the latest information, and then show it to me without loading the content. So that's why we set an alarm 2 times a day at afternoon and at 6 p.m. And we hope that our app will wake at like 5 minutes to 12 or 15 minutes to 6. Of course, we expected calls at other points of times. But what we've seen was totally unexpected. We didn't see any calls that occurs near our dates, like afternoon and 6 p.m. It was totally random. It was called at some random point of times during the day. We spent 1 month teaching the app to wake up at 2 particular time during the day, but no luck. So the only conclusion we made, according to this, you can't use this feature to prefetch some data and to show user some fetched information. I think it's like misleading information from Apple that you can't use to make your app. Of course, we made some limitations, and we're trying to make our app live in background as long as possible, because user wants their photos to be uploaded as fast as possible. The first thing we try to do is push notifications. So as I said before, you have 30 seconds after getting push notification to your device. So we thought, why try not to make notifications arrive every 30 seconds to keep our application in background for as long as we need. So, but silent push notifications, as the usual notifications, some of them fails to be delivered, and some of notifications are treated as spam. So, for example, if you try to send 1,000 notifications in 10 minutes, most of them will be failed to deliver. And there are even worse things that can happen with your push notifications. Except you lost your ability to sync in background, your user won't receive usual push notifications. So if we talk about, for example, WhatsApp, user won't see any information about new messages, and it's totally bad. So that's why if you're going to bomb your devices with the push notifications, be careful about this. You can lose your ability to deliver notifications. Another problem we've met, that some users think that App Switcher is a place where their app lives and really takes their battery, really takes their RAM and makes other apps run slower. Especially, problems arises now even more because really old phones like iPhone 4S is still supported under iOS 10, and iOS 10 is really slow on them. And people start to swiping their apps and removing them from App Switcher. It's really a strange thing because it doesn't affect somehow the performance of your phone. Apple knows it, developers knows it, only users doesn't know that. The problem is, if you remove your app from App Switcher, you won't get background fetches and your app won't live in background. That means that until your user launch your app again, you won't be able to do anything in background, and it's totally bad. So you can do nothing about this. And after releasing our first version, we met with Apple engineers and asked them about this. So what we should do? They said that nobody can do anything about this. If user removes you, then sorry, you're not called in background. So another problem on the right. So it's not so popular problem because it's really hidden in their settings. You can disable background app refresh, and for some reasons, some users disable it for particular apps. We didn't see much of users who did it, but it was about 5% of users who disabled this. Luckily, some of them write to support and says that background synchronization doesn't work. So our ops explained them that background app refresh is that what they need for background app refresh. So disabling this disables background fetching, all this stuff. Another thing is important about this thing is that some of the users concerned that you might download a lot of data while you're in background. And for example, if they are walking outside where they don't have any Wi-Fi, can cost a lot of money for them because you can download really huge file, and that's not what they need. That's why in your app, if you're actively downloading or uploading something, you should consider adding a special setting over which network you can upload and download file. So on Yandex Disk, we have a special switch that you can turn on or turn off uploading via Wi-Fi or Wi-Fi and mobile network. Also, another problem arises when your user's phone on low battery. There is a special thing when your phone goes below 20% that's called battery save type, or I don't know. So you can turn on this and your background fetches won't work. Still, there's no way to enable your fetches in that cases, and you have to live with this. You should hope that users are smart enough to keep your app running in background and won't turn background app refresh. So another part of my talk is testing. I'm not a tester by myself, but we have to talk a lot with testers about background features, because first of all, it was really unpredictable, even for us, and it was even more unpredictable for testers. Because for tester, our code looks like black box that sometimes, like 5 or 7 times a day, wakes our app, do something, and then goes to sleep. So, and testers asked us how they should test it, because there's no way to trigger refresh or trigger background fetch. So there's nothing they can do. So I will share some techniques that we and testers use. So the first one is, of course, testing with Charles. I think most of you knows what is Charles and how we should use it. Other option is Wireshark. I think which one you like more you can use. So the powerful feature is sending their prepared files. So for example, if you make a request, you can just return JSON from your own computer. And with this, testers can mock the responses without asking us to make something for them, special build. Another thing is just a purely programming thing that we're trying to apply. We tried to apply in Yandex, and I'm still trying to apply it in Coins right now. And I ask all developers who work with me to do this thing. So we're trying as everywhere as possible. We try to inject things. We don't make constructors inside the class. So everything that can be injected should be injected. So I will show you an example that allows you to test your APA class. For example, you make a data task protocol that has one function, resume, that you would like to test. And the real class is data task that should be tested against this. So if you're not familiar with Swift, I think it's obvious. So it just makes a protocol and declares a function that is in protocol. And NSURLSession data task already have this function, so you don't have to do anything else about this. Also, you need to make a URLSession protocol that has one task, one function that takes URL, completion handler, and returns our protocol instance. So here's implementation. After you've done this, you can create your APA manager class as following. So you inject your session, you don't build it inside your APA class, and you store it as a local variable. And after this, you can do the following code in tests and in app. So if you have a test API manager, you just inject mock URL session. If you're working in your real app, you inject real URL session. If you do it manually, you're going to have a bad time. So that's why we used 2 major frameworks for injecting. The first one is called Typhoon. It's built in Objective-C, so that's why we don't like it. We're trying to make Swift use Swift as much as possible. So the second one is Inject. It's really powerful. It has a lot of Swift features and it's easy to use. So like spend 1-2 days understanding how it works, and it will improve your code. It will improve the stability, because writing code in this way makes your code more testable. You have smaller classes, you have less dependencies that are inside their class, and it's easier to test. So another thing that we used is logs. So I don't show you our logs because it doesn't make sense. So believe me, we have a lot of logs. All logs in our application are meaningful, so we don't have NSLog and then just a variable. First of all, we don't use NSLog at all. We use logging frameworks. So for us, it was Kakao Lumberjack. And all of our logs have tags. For example, if you're working with some class, we tag it with the class name. After this, we can easily grab it and see what we actually need. So the only thing left for us is teach our testers to send logs. Even more, we have a feature in our application that is, of course, not popular between users. We tell only to users who has some concerns or have some problems. They can tap special button and then they will have logs for their application. After this, we just grab it and see how it works. So testing with logs is much, much simpler and helps you to improve your app. So now I'm going to share with you our best practices that we have for working on the app for 2 or 3 years. It's not a super secret sauce and not a silver bullet, but I think it will help you to make your apps better. So I will talk about Photos Framework challenges. For the last 2 years, we used Photo Framework and AV Assets, but I will tell you about Photos Framework. I will tell you about uploading state machine. Also, I will tell you about our modular architecture and about completion handler invocation. Also, another important thing is app restoration, and it's really tricky for people who start working with background, and a lot of crashes occurs there. So, first of all, let's talk about Photos Framework. As I said before, 99% of users of iPhones make photos, and they try to upload them. The situation was really simple, like 4 years ago, maybe 5 years ago, when you can only take the photo. On the last iOS update, you're now able to apply filter. You're now able to make a live video, or you can make a burst, and you make a lot of different things with photos. It's cool for user, but it's a headache for developer. Here is a prototype of the function that makes you to create upload task. The first parameter is the place where you want to upload, and the second one is file URL. It's a URL in your sandbox. Luckily for Apple, they didn't solve the problem of moving your photos to your sandbox, but bad for developer. So you have to somehow move your photo to sandbox. But some problems arises when you are using page asset, that is base class for Photos Framework. So page asset is a special thing. It's like a proxy. It doesn't give you direct URL that you can use to copy it from photo app to your app. Also, it can be burst or live video. That is really a headache. So instead of 1 photo allocation, you get 5. Or you get a video there, which is also unexpected. It also can have filters. That's why you get 2 files. The original one and delta that apply to original one to get the new one. So for example, if you take a photo and then make it grayscale, the first one will be the original and the second one will be gray delta. Also, to make sure that your server is not dying of disk shortage, you need to calculate hashes before uploading files, because nobody wants to have thousands of duplicates files on the backend. That's why you calculate hash before uploading, then see if server has this file, and then upload it. Calculating hash is a really complicated task for big videos. As I said before, like 4 or 5 years ago, 2 gigabytes video wasn't really popular, but now like 10% of video that we get on Yandex Disk is size of 500 megabytes and more. That's why you can take the whole file and calculate the hash. So you should do it iteratively on small chunks. The problem arises that before introducing Photos Framework, Apple has interface that allows you to read the file in chunks and then calculate the hash. With the Photos Framework, they lost the ability. I don't know why. They deprecated this API, so you have to do something by yourself. So another thing is that Apple tries to enforce users to use iCloud as much as they can. So now you can buy storage and store all your photos there. And photos somehow seamlessly syncs with your device, so user can think that the photos are in their phone, but it's not there. But still, page asset will return the information about this photo as it's in device. So it's also another problem. As I said before, we've met problem with copying page assets to Sandbox. It can be done really simple, but calculating by chunks is really complicated. I think we were one of the first teams who, at least in Russia, who met this problem because we hardly tried to Google. We asked questions of Stack Overflow, we asked our colleagues from different teams, nobody done this. So, but we found one solution. It was from our competitor's product, from Pavel Osipov, and he did the solution that allows you to convert page asset to the old file, to AV asset, and then to stream this file. It was a good solution for 1 or 2 years because later it can be deprecated and change the way it works. So we spent like a week or two to create our own solution. And now we have our own stream, so it's now open source. You can go to this GitHub repository. It's a repository of my colleague. And you can download it there and see how it works. If you have any questions either on the left or on the second one, on the right one, you can ask me or just mail me. I will explain how it works and what you should do about this. So another thing is upload a state machine. It's a really cool feature, and it helps us to divide our uploading logic into small parts. It makes your code testable. It makes your steps very small. So, for example, to upload file, we do some calculation before. We check redirect location. We check file size. We check permission, and all the states can go in different sequence. And that's why we have to test every step very good, because if we have a problem in one step, it will break all state machine. We also try to make reactive code and have a reactive code for uploading files, but we realized that it's just a big pile of code with a flat map and all this stuff, and newcomers can't even read this because nobody understands what it's doing. And we found ourselves that we stopped understanding what it does like in a week. So it's also really hard to test. So the idea is, if you have some complicated logic, try to move it to state machines. It's easy, it's testable, and it makes you write code that is testable and small. Also, I'm going to talk about modular architecture. So for us, we have 3 ways of interacting with server. The first one is data. It's regular requests like getting user information, asking server how much user space has, and etc. So another one is upload. We send all our files to upload in a separate session, and download is the session is for downloading files. Before starting, we have one session for all, and we find that there were troubles understanding what task we're doing and why there are some particular tasks. So the idea is, if you have similar problem, just divide it into 3 parts and make it testable separately, and make a manager that handles all interaction between sessions. So for example, if you need to upload something, manager goes to upload session. It's easier, testable, and it's better for our product. So again, about completion handler invocation. As I said before, there were 3 features in iOS 7 that can wake your app. The first one is remote notification that provides you some code that should be called after you finish your work, so it's a completion handler. Another one is information from NSURLSession that your task has finished, and you also get completion handler that should be called. And the third one is information about background fetch that wakes your app. So there are 3 types, and some of them can occur simultaneously. And this is the real problem, because you don't know which one you should call and when you should call. To avoid confusion in our code that handles all of this, we create a completion manager. It's a special class that handles and ensures that the code is performed in 30 seconds after the first handler was called. With this, we stop 100% sure that all completion handlers will be called at right time. We also write a lot of tests on this completion handler manager, and now we don't have any issues with the completion handlers. Another thing is app restoration. It's also an interesting problem that newcomers to background programming have. So for example, you have your app, and your app launches the task. Then it goes to background, and user thinks that your app takes a lot of memory or their phone is really slow, and then just throw your app out of App Switcher. Okay, it's a user's decision. After that, your task finishes, and user starts your app again. An NSURLSession informs your app that task is finished, but the problem is your app that is launched after it was removed from App Switcher doesn't know about the task. It doesn't start any task. It doesn't have any session related to this task, and it's totally new session. So app doesn't know anything about this, and if you're not very careful about programming this, you're gonna get crash. So there are two types of situations. The first one, if you get your app started before receiving the task. With this, we just restore all the tasks from our sessions, and we're making our completion handlers to handle all finished tasks, and we create blocks that display progress in our UI. So another thing is that when your app is woken up by finished task, and your app doesn't know anything about this, so we also restore our completion handlers. So to make sure we know which one is called, so to understand which file was uploaded or failed to upload, we use a special field called task description. It's stored on the task, and it helps us to understand what happened with which file. And the last thing I'm going to talk about is improving user experience. The thing that we use, that I use right now in my application that I'm working on right now, and there is like suggestion for an example from another app that can also can benefit from this feature. So in my app that I'm working on right now is there's a KYC. So there is some flow that users should finish before start sending money or receiving money, and one of them is selfie. So users should take a selfie and then upload it to our servers, so we can verify that it's a real user. It's not someone who would like to steal money or mislead somehow. But the thing is, in the Philippines, internet is really, really bad. It can take like 5 minutes to upload one photo, especially in some villages far away from capital. So, and with this UI, as you can see, there is like a blocking UI, and we ask user to keep their phone running and their app running in foreground, and don't do anything. But with the background uploads, you can have no waiting here. You can just send them to dashboard and upload data in background. So I think it's really, really great step for users, because it helps users to see what your app do, and improves your chance of, it improves the chance that user will use your app. So another example, I'm not sure it's popular in Prague, but it's really popular app in Russia. It's called DoubleGIS. So it's a navigational app that can download your map to your phone, and then you have a transport map, you have a location map, and all phones and all the stuff in your phone. But the problem is these maps get outdated, and I, as a user of this app, don't want to sync all the time all my maps. So as improvement for this app, we can add background synchronization. And for example, as long as new map is released, it can be downloaded automatically to my phone. And it's really a huge improvement for this app. Also, there are a lot of different examples, and there are a lot of popular cloud storage. So you can take a look at them, and the next app that you're working on can benefit from them. So I think that's all for today. If you have any questions, then you can ask me. Thank you.